Okay, so let's see this problem in topology. Now, this is a very interesting problem in its own right, because it characterizes Hausdorff topological spaces, and moreover, this particular statement has been seen in many competitive exams. For example, in NBHM 2019 PhD entrance, I guess this exactly this statement has come up in a question, and I guess this has also been asked in CSIR net as well. I don't exactly remember the date or the year. Nevertheless, this is a very important question from general topology. Okay, and let's see what is the question saying. So the question says that let X be a topological space. Okay, let me try to change this color a bit. So let X be a topological space, then show that X is Hausdorff if and only if the diagonal, which is defined like this, is closed in the product topology. Okay, so let's quickly go through the proof, and the proof will actually be very simple. Okay, just observe that how we come up with this, and you will be able to understand that why is the proof structured in this way. Suppose we first assume that let X be Hausdorff. Okay, then what do we know? So this implies for all distinct points in X, there exists disjoint open sets, let's say Ux and Uy, such that X is in Ux and Y is in Uy. Fine. But then that implies that X cross Y is contained in Ux cross Uy. Is it clear? So this is something which we will be using. Okay. Now, what do we need to show? Now to show that delta is closed. But equivalently, we can opt to prove that delta complement is open. Why are we doing this? Okay, that's exactly why I just wrote the previous statement. The reason is, how do we write delta complement? Delta complement is exactly those set of points coming from X cross X such that the coordinates are different, but both of these are coming from X. So we have a pair of distinct points from X. So therefore we can separate it using two open sets, right? So now if XY is in delta complement, that means there exists disjoint open sets Ux and Uy such that XY is contained in Ux cross Uy. But now I need to prove that delta complement is open. So how do we show that that some set is open? If I choose any arbitrary point from it, I need to show that there is some open set which contains that point and which is completely contained inside that set, right? So how do we show this? So I need to show that this is completely contained in delta complement. But it is quite immediate, right? Because if I choose any point out from here, for example, say alpha beta, then alpha equal to beta would immediately imply that alpha is in the intersection of Ux and Uy. But that's a contradiction, because Ux and Uy are disjoint sets. So therefore, any point I choose out from Ux cross Uy, the coordinates of that point are to be disjoint. Therefore, it must be completely contained in delta complement. What does that mean? That means that delta complement is open, which equivalently means that delta is closed, right? And the converse of this statement will also come up in a exactly same way. For example, let right, so how do we prove out the converse? So what do I need to show? So suppose let delta be closed. What does that mean? That means that delta complement is open. What does that mean? That means that, so therefore now let XY be in delta complement. So since it's open, so there exists some open set, let's say Ux cross Uy, such that XY is in Ux cross Uy, which is completely contained inside delta complement. And we are done at this step, because if I need to show that X is Hausdorff, so let X be not equal to Y in X. What does that mean? That means that this ordered pair XY, this comes from delta complement, which implies that it is actually contained in some open set by the above structure. I'm not repeating it which is contained in delta complement. But since this is contained in delta complement, these are open sets by definition of product topology. Ux and Uy are individually open in X. So this means X is in Ux open, Y is in Uy open, and Ux intersection Uy is empty. Otherwise, this open set would not have been contained inside delta complement, because if there was some element in the intersection, then that element would form a double pair, right? Double paired in X cross X, so it won't be contained in delta complement. So it has to be empty. What does that imply? That implies that X is Hausdorff. And this was exactly what we required to prove. So thank you. Do like and share, and we will come up with similar problems soon.